So now we'll be discussing some of the important rules in differentiation. So for example, if we are having two functions u and v, and we are taking differentiation here. So when two functions are added together, u plus or minus v, if it is addition or subtraction, and when we are taking the differentiation of the whole function, what we can do means we can distribute the differentiation to each of the functions. So u dash plus or minus v dash, just distribution. And if we are having a product rule, like when we are having product of two functions, you cannot do the direct distribution. We have a special rule called Leibniz rule or product rule. So when we are taking the differentiation of uv the whole dash, what we have to do means you have to take the differentiation of the first function multiply with the second one plus the first one multiplied with the differentiation of the second function. For division, we have another rule called quotient rule. So when we are having u by v the whole dash, it will be u dash v minus uv dash by v square, the denominator squared. So now using the first rule I have told you, we'll be discussing a question here. So our y function, it's given as sin x plus tan x plus 3, and we have to find out the y dash. So in order to find the y dash, what we have to do means we have to take the differentiation of dy by dx, and we can distribute the differentiation between each of these terms. So d by dx of sin x, because it's just plus, right? Plus or minus, we can distribute it along the terms. Then plus d by dx of tan x plus d by dx of 3. So the derivative of sine is cos, and the derivative of tan is sec squared. And in order to find the derivative of this, you can use the formula 3, right? And there is no x here, right? So it will be 3x raised to 0, right? Instead of 3, we can write it as 3x raised to 0, because any variable or any number raised to 0 will be equal to 1 itself. So here if you check, instead of the power, we are having the 0 here multiplied with the variable raised to the power minus 1. So this whole multiplication, it will be equal to 0 itself, because we are having a 0 here. So this part will be equal to 0. So we can say that the differentiation of any constant, it's actually equal to 0 itself. So if you're having any constant here like 3, 5, c, anything, like for example c is a constant, then if you're taking the differentiation of that, it will be equal to 0 itself. No need to do the calculations. So if you check the derivative, it will be just cos x plus sec squared x only, because this is a constant and we got the derivative of 0 here. So only this will be left out. So the derivative of this function is this one. So here we are having a question for the product rule or Leibniz rule. So here they have specified our y is 2x squared cos sin x, and we have to find out the y dash. So for this one, why we are calling it as two different functions means, here we have one x variable and here we have another function of x variable. So two different places x are there in two different forms. Here in terms of like a polynomial function x squared, and here in terms of sin x. So two different things are there. So we have to find out the derivative. So we have to use the product rule. So for finding the y dash, we can specify our u as 2x squared and our v as sin x. So y dash will be equal to d by dx, the derivative of u dash, right? So it will be 2x squared multiplied with the sin x plus Now we have to write the first one as it is 2x squared multiplied with the derivative of the second function. So it will be sin x. Now if you check, this will be 2 is a constant, so we can write it we can take it outside the differentiation also. We'll be only doing the differentiation with x squared here. So d by dx of x squared will be, first we have to write the power, then x, then raised to the power 2 minus 1. So 2 minus 1 will be 1, right? So we can write it as 2x itself. Then it is multiplied with sin x plus 2x squared, and derivative of sine is cos. So if you check, the final answer would be 4x sin x plus 2x squared cos x. So this is the final answer. So when the constant is coming along with some term, for example here it has come along with x squared, right? So here no need to take the derivative as 0, we can apply the formula and we can write it. But when it is coming alone, then the derivative will be equal to 0 itself. So here we are having an example for the quotient rule. So y is equal to 2x by cos x, and we have to find the derivative of this whole function. So for this one, first we will be taking the derivative of the numerator, so 2x. So here you can use this rule itself. The derivative of x with respect to x, it will be equal to 1 itself. So if they are asking dy by dy, it will be equal to 1. When the numerator and the denominator are same, it will be 1 itself. So here the derivative will be equal to 1. So the derivative of 2x we have to find here. So 2, no need to take the derivative as it is a constant coming along with x. So what is the derivative of x? It will be equal to 1, and this is multiplied with the denominator, which is cos x. So 2 into 1 into cos x minus, and our numerator will remain the same, 2x, and b dash, our denominator, derivative we have to take. What is the derivative of cos x? It is minus sin x. It's c, right? So it should be negative. So cos, cosec and cot all are negative. They have derivatives as negatives. Now the whole thing is divided by v squared. So our denominator is cos, so v squared will be cos squared. So it will be 2 cos x. Actually we can distribute the denominator here. See, it's common, right? We can distribute it here minus this here also. So 2 cos x by cos squared x minus, and here we are having minus and minus here, so it will become plus. So it will be plus 2x sin x by cos squared x. So it will be here 2 by cos x, because one of the cos in the denominator gets cancelled with the numerator 1. 2 by cos x plus 2x sin by cos, and we can write it as 1 by cos also, because 2 cos are there in the denominator. So 1 cos we are dividing with sin, and another one there's nothing left, which is a trigonometric function, so we'll be dividing it just by 1 itself. So what is 1 by cos x? It is sec. So it will be 2 sec plus 2x, and sin by cos is tan, and 1 by cos is secant. So this is the final answer. This is the differentiation of this function given here, 2 sec x plus 2x tan x sec x.